3x plus y plus y, and it's constrained to x squared plus y squared x squared plus y squared equals to 10. Very well. So since you have two functions, let us apply Lagrange multiplier. We have two functions. So the first one is f of x and y, which is 3x plus y, and the second one, g of x and y, your constraint, which is x squared plus y squared minus 10. To apply the Lagrange multipliers, find the gradient of f, find the gradient of g. What are these two? So the gradient of f, which is equal to the vector function f of x and f of y, equals to the gradient of f is 3, 1, just fix the vector, and the gradient of g is equal to, well, you're going to have a vector function 2x, g of x and g of y, 2x and 2y. Now we know that the optimum value for f happens when the gradient of f is parallel to gradient of g. Now set the gradient of f equals to lambda gradient of g. 3 and 1 is equal to lambda 2x, 2y. The rest is algebra. Algebra says 3 and 1 is equal to 2 lambda x, 2 lambda y. The first components must be equal to each other. These are just simple vectors. The second components must be equal to each other. Well, what do we have here? It says, okay, 3 is equal to 2 lambda x, and 1 is equal to 2 lambda y. So, there you go. How we can analyze this? Which method is most helpful here? Should I just plug in random values for lambda? Should I isolate lambda on one side and substitute that? Should I divide these two? Should I multiply these two? Which method? Well, one thing that comes to mind is, okay, I have two equations. Somehow I want to get rid of lambda. And also note that you have another equation to keep your eyes on. This is another important relation between x and y that can help you to find the values for x and y. So from these two equations, what you can do, you can either isolate lambda on one side, substitute that in the second equation, or you can divide these two equations. Both of them work. So we can isolate lambda on one side, then substitute in the second equation, or just divide these equations. Okay, if you isolate lambda on one side, you get lambda equals to 3 divided by 2x. So let's call it 1 and 2 From 1, lambda is 3 over 2x, and substitute in 2. From 2, you get 1 equals to 2 times 3 divided by 2x times y. You're finding a relation between x and y. So x is equal to 3y. I found the relation between x and y. I also have another relation between x and y. Also, x squared plus y squared is equal to 10. So just substitute this guy here. X is 3y, substitute that in this equation, solve for y. So you get 3y squared plus y squared equals to 10. So you have 9y squared plus y squared is 10, or 10y squared is 10. So y is plus minus 1. Y is plus minus 1. So what is your x? X is, if y is 1, then your x is 3. If y is negative 1, then your x is negative 3. So what are those points? 3, 1, negative 3, negative 1.